This question is an example of when we're using linear motion and angular motion in the same question. What we're told in the question is that winch drum is rotating and it's lowering a load. So the movement of the drum is going to be angular motion and the movement of the load is going to be linear motion. In the question, we're asked to find the length of the rope that's going to be wound out from the drum during a period of braking. So let's have a look at the information we've been given in the question. We're told that the diameter of the drum is 500 millimeters. So that's the first thing that we'll write down. And remember, we're going to be working in meters throughout this, so we want to convert this. And since there's 1,000 millimeters a meter, this is 0.5 meters. This also gives us the radius, because the radius is equal to the diameter divided by 2. And so our radius here is 0.25 meters. And we'll need that when we're using our bridging equation later on in the question. We're also told that the initial angular velocity of the drum, omega 1, is 300 RPM, and that is the same if we use our formula 2 pi n over 60, 2 pi times 300 divided by 60 to turn this into radians per second. So that works out as 10 pi, or if we want to calculate it out, 31.42 radians per second. We are told that it comes to rest, so we know omega 2 is going to be equal to 0 radians per second, and we're told the period of time for which this will come to rest is 20 seconds. And we're asked to find the length of rope that's unwound in this time. So let us think about this, because we know how to move between angular and linear quantities. We have been given some angular quantities relating to the drum, and so we can use this to work out the angular displacement, how far the drum has turned in the time period, using one of our formulas of angular motion, this one here, where theta is equal to omega 1 plus omega 2 divided by 2 multiplied by the time. So in this question, what we have, and I'll just use the exact value of 10 pi before. You can put in 31.4 for omega 1, but I'll use 10 pi here to keep it exact calculator value. 10 pi plus 0 divided by 2 times 20. Now 10 pi plus 0 is just 10 pi, so that's going to be 10 pi divided by 2 is 5 pi times 20 is equal to 100 pi, or if we write that out numerically, 314.16 radians, and remember that's our unit for angular displacement. So we've now worked out how far the drum has turned in this time period, but the final thing we need to do is to work out the length of rope, so that's how far down the load has moved effectively. Well, we have a bridging equation for this. To find the linear displacement, or distance travelled s, that's equal to theta, the angular displacement, times the radius of the drum, the radius of the thing that's rotating in this question. We've just worked out theta, it's 100 pi, or 314.16 if you prefer, and our radius, well, if we go back to the start, we noted that our diameter was 500 millimeters, and that's 0.5 meters, and half of that is 0.25 meters, that's a radius, so it's 0.25. So that gives us an answer. Well, if we want it to be exact, it's 25 times pi, but we'll give it fully numerically, and that's 78.54 meters. So that's the answer to our question. When we have a drum rotating at these angular velocities in this time period, we can work out the angular displacement, and then using our bridging equation, we can work out the distance travelled linearly by the load, that which gives us how much rope has unwound in that time.